Okay, so today I go with a hard problem. So we are given two sorted arrays of distinct integers, nums 1 and 2. Valid path is defined as follows. Choose array nums 1 or 2 to traverse, current from left to right. If you are reading any value that is present in nums 1 and nums 2, you have to change. Only one repeated value is considered in the valid path. What? The score is different than sum of unique values in the valid path. Return the maximum score you can obtain. Since the answer may be too large, return the modulo 10 to 9 plus 7. Okay, this might be more difficult. So, constraints, they are increasing, and we got 10 and 5, and the numbers are 10 and 7. Okay, let's think about it. So the path looks like this. We go through num1, and we find something that will, so valid path will be this, what is this. Then go through 4 and finish, or go through 8 and finish. Okay, so that is interesting. Okay, so, well, let's say pass to 5. Those can be just pass or pass to 8. Those can be pass to 5, and the number of unique values there, plus if these are not equal, right? And then, or we go from here and it's answer for this. Now, we cannot compute a straight line here because something. So okay, so we need to find a way to compute those values. Because if here would be 1, for example, here would be 1, here would be 3, whatever. So now for this is 1, for this is 2, and now we are here. So the answer can be, or here we put 1, so the answer can be 2. And if we have 1, 3 here, the answer can be 3 if we jump here, but how do we know if we process this? So we have to process. Okay, so if we are there, we process until the values are small. So what I need is that I compute this, and then I need to also consider the jump. But we will not jump like this, that's useless. So what we need is, let's say we want to compute for like 4. So we compute it until all numbers that are smaller than or equal to 4, and then we put maximum of these two in each of them. And then you continue, and then you continue, and then you finish. If you didn't like, if we would finish here, we would go by nums 2, so we do, okay, we check 1, 4, and then put maximum here. So you can get here with 2 numbers and here with 2 numbers. Go for 6, so you finish 5, which is 3. And this is whatever is this plus 1. Okay, go for 8, so you finish this. And then question is, can numbers they are distinct? Okay, that's not difficult. So okay, let's try to code it. So let's grab the sizes of the arrays. Let's do some casting, even though it's unnecessary, I guess. So this nums 1 and 2. and then it's kind of hard to work with, but whatever. So we grab this length, and now we need to do some dynamic programming. The maximum number of distinct values can be 2 times 10 to 5 if we have even numbers here and odd numbers here. And okay, not really, because then you cannot jump. So the maximum number of distinct values can actually be just 10 and 5. So the answer fits into it. So our dynamic programming is called DP1 and DP2. Okay, we actually don't need this, I think. Okay, let's do it like this. So we go through. Let's keep it this way because the edge cases will be nice, I think. So imagine we go through. So we have a pointer in 1 which is set at 1, and then a pointer in 2 which is also set at 1. And while P1 is under n, let's declare that outside so that we can move the other one later. Okay, so we iterate over the first one, and okay, here's what we are going to do. So first we solve for this. No. First we solve it for the range P1 without considering jumping there. So that means that dpp1, so dp1 pointer 1 is equal to dp1 pointer 1 minus 1 plus so either pointer 1 is 0 or pointer 1 is 1, or nums 1 of pointer 1 plus 1, or pointer 1 doesn't equal nums 1 pointer 1 minus 1. Okay, so it's 2, and then it's gonna be I'm not sure I like this actually. So either P1 is 1, and then we check what, so that's 2 and 1, but we are interested in the first 2. Okay, indexing is I'm wobbling totally, but wait, maximum score. What is the maximum score? Sum of unique values. Okay, well that can be large. Okay, so okay, so now we are calculating. So DPI is maximum value we can. So DP1 I is maximum score we can obtain from all valid paths that end at that position and can go through values that are smaller than or equal to that value in the first array. So now dp1 is just going to be dp1 of p1 minus 1. And now so either p1 is 1, so we are on the first element, so it's definitely a unique one, or we are on the second element and they are not equal, so nums 1 p1 minus 1 is larger since they are sorted than nums 1 p1 minus 2, then p1 plus equals nums 1 p1 minus 1. Kind of dumb indexing, but whatever. So we did this update, and now we do the same update for dp2 until we are on the. So if we are on 8 and the other pointer is here, then we move until we meet this. We stop here. we don't update ask for that. So while p2 is more than equal to m and nums2 p2 minus 1 is smaller than or equal to nums1 pointer 1, then we want to do okay, well, so now when we move this, we have already computed 8 here, so we can compute this with the jumps, and we also update the maximum here. So the numbers are until 10 to 7. Okay, that's a tough one. Okay, so what I was thinking is that I need to know at which position is the 8 in the other array. Now for that we can either do it in hash map, and we hope it's all 1, or we use an array. Problem is that if the range of values are large, we cannot use array. 10 to 7 is fine. I think 10 to 7 should not die, but since there are only 10 to 5 elements, there can only be 2 times 10 to 5 unique values, so we could compress those values and keep some sort of inverse index, so that when we are actually adding the counts, we add the inverse value of the compressed whatever. But that's not necessary, we'll just use hash. So where are we? Now we are moving the pointer in the other array, so dpp2 is equal to maximum of, no, it's just, let's do, first it's gonna be the previous one, so dp2 p2 minus 1, and now if, again the same case, if it's the first element or it's not equal to, so that is the first way we can come just from the same array but previous position. So if the number changed, nums2 p2 minus 2, then dp2 pointer 2 was equals nums2 pointer 2 minus 1. And now what we want to do? Well, if that number is in the first array, so we could jump there, so we need to keep some sort of a index or there at the map, so let's store int position. We iterate over nums1 and position of nums1 element in nums1 at I is equal to I. And now if the position has the current number, then we can do the jump, so dp2 or position 2 is max dp2 pointer 2, or dp1 position, I should probably store the current number because it's repeating, so let's say long current number is nums2 p2 I minus 1. Let's rewrite it, so current number, and current number. So position of current number That's it, actually. I didn't even have to rewrite it, whatever. And finally remove the pointer. Okay, so after we have done that, one last thing, we have to update. So when we move the pointer in here, we also have to update this, because maybe we can get here to on more. Like if there will be 5 numbers here, we move this pointer and then we can jump here. So dp1 at pointer 1 is maximum of dp1 at pointer 1, and wait, so we first have to have that number in the second array. So if position has the number nums1 position 1, then it's maximum of position at nums2 pointer nums1 pointer 1, too many brackets, whatever, we take those. And finally we have to finish the loop, I think, outside. So right, we will just process 10 and then the 9 will get processed. So we finish the loop. So while p2 is smaller than m, and no, just this, we don't check the other array, and we take the previous one and we take the current num and we are at first position. That could happen if there are no same numbers. We are at first position or current number is larger than the previous one, so it's a new unique value we added there. And finally we return the maximum of those two values, so return max of dp1 back, dp2 back, and let's see if it even remotely works. Oh, overflow. Haha. Okay, that sucks. Let's try to write some indices. Position. Okay, I missed the index because it's +1. Nums2, nums1, and this should be -1, 2. Let's check it. So we have nums1, -1, -2, nums2, -2, 2, 1, 2, 2. There's dp, so that's okay. That's position of nums2, nums2, -1, -2, -1. Maybe now. Let's check. Okay, now it's overflow somewhere else. Line 34. Still here. Why? Position. I know. Okay. Oh, wait. I have to have position 1 and position 2. Okay. So the problem is that now I am checking if number from here is here, but I only store if numbers from, wait, oh my days, what am I doing? So let's do position 1. I'm only storing numbers from the first one, but I'm not storing numbers from the second one. So let's have 2 of those for int I. Okay, so position 2, position 1, nums2 I is I, and then somewhere here I use position here, so this is position 1. So because we are asking, is there in the nums1 the current number from nums2? Yes, okay, and now is in the nums2 is the number from the first array. Okay, maybe. No, this will not work. Okay. I have immediately because I am not increasing the pointer here, and there is off by 1 error because we actually care about these positions, because we are putting that position we got into DP array, which is shifting by 1. So also here we have to move it by 1, and I think that's it, but I am not sure. Maybe. Okay, so wrong answer on some test cases. Okay, we can debug. So first we print the index where we are and then value in DP1. Let's see if this shows us anything. So here it's 2, here it's 6, here it's 11. 1, 2, 3, 4, 5. Okay, that's larger actually. I think I know where. Okay, so we clearly get 29 from this. DP1 position 1 is DP1 position 1. Interesting. It was 2. So here it should be 19, because what is 4 auto x in DP2 salt x. So I'm printing, let's say what I'm doing, I'm printing DP2 because I want to see if in DP2 the value is 6, 12, 20. So it's 4, 10, 18, but it actually should be more, I think. If position 1 has current number, then we take, wait, so position 2 has, there is 6 at the start, and then at the end DP2 is this. We only move by this, so that's position 1. So current number, and then position of current number plus 1, and then DP. We don't need that actually. Okay, so let's do this. Boom. And let's see what this gives us. That's plus 1. Okay. So for position of current what even? So current number is 4, and you are telling me that, oh, I'm doing plus 1 here. Why am I doing that? Okay, so it was just not about 1 there. Nice. Boom. And let's delete also this. That's also just print. Let's run it again. And let's submit. Let's see if it passes. Wrong answer. Okay, that's overflow. So I think I should just cast into long. It doesn't for some reason. So here I add an int. This is already long. This is long too. And this is long. So let's use the test case. And let's run it. And It's still overflow for some reason. That is interesting. Okay. Oh, yeah. Maximum modulo mod. I forgot about modulo completely. Const int modulo 189 plus 7. Okay, it passes now. Boom. Should pass. Okay, great. It's slow, but yeah, that wasn't too hard. But I spent a lot of time. Easy, easy. Or let's call it simple. So intuition. To each position in a valid path to some position in either array can come from the previous position in that array or by jumping from the other array. So that's the intuition. So we iterate, we use the dynamic programming to compute the maximum score of a valid path. And compute it for primarily for the first array. For each position, we first compute the score of getting there from the previous position of the same array. Then we compute the before then we have to take the maximum of the computed value and jumping from the other array, but we have not computed that yet. We can calculate the missing values from the other array by simply moving its pointer, moving along it and computing the maximums until we reach and including we reach largest number same or equal smaller than or equal to the current number in the first array. This will work because we have already computed all the answers for smaller numbers in the first array. For smaller or equal numbers in the first array. Finally, we can update the maximum in the first array. We do this two pointers approach. Let's call it 2 pointers plus BP, 2 pointers plus BP. we do this two-pointer approach for all positions in the first array, and all positions in the first array, and then we just move the pointer to the end of the second array, and if it's not already there. If it's hard to understand, just look at the code. Time complexity. Okay, so we go for each position in the first array, and we do some O1 calculation here, and then we move the pointer, and then again do O1 calculation. This pointer is going to be moved total m times, so the total work is just O of n plus m, where n is the size of the first array and m is the size of the second array. Since we do O1 work calculating the values and move each pointer n and m times respectively, space complexity O of n plus m, since we store the entire DB. Oh, we can optimize it. Yeah, not really. Okay. Since we store the entire, we could use only the previous values, but since we may need many previous values if you get to the end, and then there is a value from here, we need to move this pointer, and if all match, we need all of them, so we cannot use the trick, but since we store the entire BP arrays, since we have to store the entire BP arrays for both arrays of numbers, post okay, not the hard problem.